Hi, welcome to Wise Guys. Naming compounds. Binary ionic compounds 2. A binary ionic compound contains two elements, metal and non-metal. Last session, I show you naming binary ionic compound with fixed positive charge. And this session is for an binary ionic compound with variable positive charge. So how do we know a metal is positive, fixed positive charge or variable positive charge? So this is you can find all the information from periodic table. So let's look at the periodic table again. So we already know the first group and second group are strong metal except the hydrogen, because hydrogen actually is non-metal but with positive charge. That is exception. But mostly start from lithium, sodium, potassium, and barium, magnesium. All this second group, first group are strong metal. They have fixed positive charge. The others metals stay in transition part called transition metal. But some transition metals still fixed, right? Like zinc, aluminum. But a lot of transition metal have the variable positive charge. For example, copper have copper 2, copper 1. That means sometimes depend on which the other non-metal element they combine with, and so sometimes they have 2 positive charge, sometimes 1 positive charge. Iron has 3 positive charge, 2 positive charge, and also mercury, lead has variable charge. So let's look at the how to naming this kind of stuff. Okay, using periodic table of ions, first you need to identify transition metal ion with variable charge. And second, use charge balance to calculate the charge of metal ion, because we need to make sure, like for example, iron, if it is 3 positive or 2 positive. All this is using charge balance to calculate the charge of metal, because a compound, the total charge is 0, which is neutral. So that means the total positive charge has to be equal to total negative charge, right? So the third one is name metal ion with Roman numeral to represent the charge of metal ion. 4 write as metal ion followed by non-metal ion. So let's start look at the 2 examples. First example, naming FeCl2. From periodic table, we already know iron is transition metal. Transition metal, iron, atomic number 26, and has 3 positive or 2 positive. And chlorine is negative, is non-metal, always has fixed negative charge, which is -1. So now, let's working with this question. First of all, we can write Fe and the Cl2 is red color represent metal, green color represent non-metal. The bottom, the subscript represent how many number of ions. The Fe no number, that means 1 ion. Okay, because we don't need to write one ion. Okay, and the chlorine has 2 ions. Because chlorine we already know is -1 charge, so the total charge from negative ion is -2. 2 ions, each one is -1, so 2 is -2. You need to plus the total charge from iron, because it is positive. Possible 3, positive 3, positive 2, we don't know, so we need to check this one. The total charge, the positive per negative has to be equal 0. So you can see how to do this question. Obviously, this is a positive 2, right? Positive 2 per negative 2 equals 0. So because only one ion, so that's why this ion is with 2 positive charge. Once we figure out the ion is positive 1 charge, a positive 2 charge, then we can name it. We use Roman numeral to represent the charge of metal. So we write iron 2, we should represent the number of charge of iron. Iron 2 chloride. Okay. The second example, naming Cu2O. Cu is copper from transition part. And we can say copper has positive 2 or positive 1. Right? Copper has positive 2 or positive 1. Copper 2 or copper 1. Okay, let's figure out in this compound copper, if it is copper 1 or copper 2. So we also write copper is metal, right? Use red color, Cu. There are 2 ions in this compound. And no metal, oxygen is only one ion, right? Only one ion. As we know, oxygen is always -2. So the total negative charge is 1 times 2, -2 equals -2. Plus the total charge from positive side has to be positive 2, so that they can make 0 charge. So that's why you see the copper is 2 ions. Each copper ion in this situation is +1. So that's why in this situation copper is 1. With 2 ions, each one is 1, total is positive 2. Positive 2 per -2 equals 0. That's why we name it as copper 1 oxide. Okay? So next is your turn to practice some question. I have 4 questions to let you practice. First, you can pause the video, then after practice, then come back. Okay, welcome, come back. The first 2 example, first 2 practice question is naming CUS, naming Fe2O3. So the answer is CUS is copper 2 sulfide. Let's figure out. Copper is Cu and S is sulfur. Because the bottom both is 1 1, that means 1 ion, 1 ion, 1 ion for sulfur, 1 ion for copper. Because as we know, sulfur is in group 6, so with 2 negative, the total is -2 charge, and it has to be positive 2 charge from copper, so that they can make 0 neutral, no charge at all. So that would mean this situation 2+, right? So the copper 2 sulfide. Namely Fe2O3, also we can write Fe, have 2 ions, and oxygen with 3 ions, because oxygen 2 negative, so total is -6 charge. So what about the charge from iron, so that they can make 0? So it has to be this positive charge, +6, +6 plus -6 equals 0, because there are 2 ions, so that way each ion has to be 3, +3. See? 2 ions, each one is 3 positive multiplied equal +6, and 3 ions for oxygen, each one 2 negative multiplied equal -6, total equals 0. Right? This is the first question and the second question, and you can practice. Next is the question 3, question 4. Have video pause and practice, then look at the answer and come back. Okay. Welcome, come back. So what is the name of PbCl4? Pb? Lead. Cl4. So chlorine is -1, total is -4 charge. And the lead, only 1 ion has to be +4, so that they make 0. So that means this one has to be +4, right? So lead 4, Roman numeral, lead 4 chloride. Hg is mercury, 2 mercury, 1 oxygen, 1 oxygen, each oxygen 2 negative. So total is -2. And mercury is 2 mercury, total has to be +2, so that they can make 0. That's why this is 2 mercury, each one is 1 positive. So the name is mercury 1 oxide. Okay, this is presented by Wise Guys. Thank you. Have a nice day.